Hello, hope you people are doing well. Before I start the discussion of the third chapter, I would like to address a few issues. Firstly, it is regarding some noise interference while I'm recording. I am trying to learn some audio enhancing program to remove that noise and that stuff. It would take a couple more videos before I'm able to learn those things and apply it. I apologize very much for the noise uh, which is present in the videos. And secondly, about the my English accent and those things. I'm not very much fluid with English and comfortable in speaking this language. Please also apologize me if I do make some errors while speaking or I'm not very much fluid. Okay. Also, I would like to acknowledge a few errors that I did in the previous lecture. Firstly, it was regarding the bool type. Okay, and then the bool type, it has a size of 8 bytes. It is officially mentioned on various sites and also good sites like CPP reference and C++.com. That was one thing, and the other thing was that regarding a int size type, I said that for 64-bit machines, the size is 64-bit, but it's not exactly. In 64-bit processors, also the size type is only 32-bit. It should have been 64-bit, but people got so much used to 32-bit that they said that okay, let's make it 32-bit only on 64-bit processors also. But if you go to your 16-bit processor, then you will still find the size in accordance with your processor architecture. So for 16-bit, it's 16-bit. For 32-bit, it's 32-bit, and for 64-bit, it's your 32-bit. Okay, now we will formally start the discussion of the third chapter, strings, vectors, and arrays. Okay, so first of all, I would like to explain what we mean by this namespace. Okay, many of you who have done C++, not exactly done C++, even if you are starting to code, then at many places you must have used using namespace, std, and those types of things. So what exactly do we imply by namespace? Okay, so C++, it allows the use of namespaces. Okay, so namespace means that within a particular your declaration, you are able to specify your names, and for different declarations you can use the same names. For example, if you are using your cout. Okay, in the standard library we have declared your cout. Okay, in the standard library we have declared your cout. We can make not standard library, in the std namespace we have declared your cout. Okay, so std is used to refer to standard. Okay, that has been said by your C++. But supposedly if you want to use a different namespace and you want to redeclare the cout, then you can do that. Okay, so namespace, it is very much helpful in maintaining your versions. Okay, for example, some company uses some versions, some company uses some other. Okay, basically it is used for declaring your global variables. Okay, which have uh, under different namespaces. Okay, so means cout can act differently if declared in some other namespace. For example, uh, if you write abc, you can do this also, abc cout. Okay, so cout will behave in accordance to what how it is defined in the ABC namespace. Okay, so many companies use these namespaces for maintaining versions and those things. Okay, so STD is the basic namespace that you would be dealing with, and not for now you would be using uh, you would not be constructing namespace till like further 6-7 classes. Okay, so this is a late concept. This concept will come later. Okay, so I will just show you an example. So if if you don't use namespace, then the general declaration for cout is std with this scope resolution operator and then cout. Okay, so this scope resolution implies that cout it belongs to your std. Okay, so it belongs to the std namespace, but you can use using namespace. Okay, like when you write in your header files hash include iostream, and then you write using namespace std. Okay, so if you have written using namespace std, then you can freely write your cout one and all the things that are included in the namespace std. Okay, so it also includes your stdcn, so you can just write your cn x whatever variable. Okay, sorry, I wrote xcn, so you can just write this also, or else you can write using stdcout. Okay, so in this case you are not mentioning any particular namespace, you are just mentioning this global variable. Okay, so in this case cout can directly be used in the whole file. Okay, so in this case you can't just write cn x. uh, this is wrong. Okay, so this is not the right thing to do. Okay, this is not the right thing to do. Okay, so next, if you want to use cn, then you have to then write std your cn. Okay, so this would be the proper way if you are not writing using namespace std. So you have to write using you have to just write stdcn separately. Okay, so this is done. Next we have okay, now we are done with your namespace. Okay, then we would now start with your strings. Okay, so basically what we will be discussing would be strings, vectors, and your arrays. So strings and vector, these are very much easy things. Okay, so there are just some functions that you have to remember, and it's not so much complicated as the topic of arrays would be. Okay, so let's start with the definition. So your string is a class. Okay, so basically it is a variable length sequence of characters, and if you want to use strings, then you have to include the string header file. So the header file would be hash include string. Okay, or hash includes c string. I would discuss what we mean by c string afterward. Okay, so next we move on to your initialization of strings. So let me just check what I. Okay, no, I'm not it. Okay, so the initializations that are there, these are default, direct, and copy. So these are the ways of initializing your string. You just have to remember them. String s1. This is your default initialization. It will initialize a string s1 which has no characters in it. Then string s2 bracket sorry parenthesis s1. It initializes a string s2 which is a copy of s1. Then string s2 equal to s1. S2 makes a copy of s1. Then string s3 value. S3 has this literal value, string literal value, whatever you have put over here. Okay. Next we have string s3 equal to value. Again, the value is copied here. Then string s4 n comma c. So S4 has n characters, uh, n characters which are C. Okay. So if I supposedly n was 10. Okay, not 10. 10 would be very much large. Sorry, not 10. Okay, supposedly S4, supposedly n equal to you say 3. Okay, n equal to 3, then in that case S4 would be equal to your C. Okay, so three C characters would be copied into this string. Okay, so these are the ways of initializing. Okay, you just have to remember them, and they are not so much difficult to remember also. Okay, this is your constructor method of initializing S2 uh, parenthesis S1. It is basically a copy constructor, if you know a bit about classes, and this is also a copy. So these three are very much basic. This is also basic. Okay, and the only exception here is that we are using string literals, so it would be of type const chi star. So these five are very much basic and pretty intuitive, I think, to remember. Okay, the last one is something which you could feel is newer. So you can put some effort in remembering this. Okay, so we are done with this. One more thing that I would like to comment upon is that in strings, there is no storage of your null character at the end. Okay, so if, for example, if you saw your earlier C type characters strings, then in those type of string, if you were writing something like even hello, okay, if you are writing hello, then it would store a null character at the end. But in the case of strings, there is no null character at the end. Okay, so this is also a difference between your string and your C style character strings. So next, we move on to the operations on these strings. Okay, so these also you have to just remember. So the first operation is your O stream insertion S. Okay, this operator. So it, it what it does is that it writes S onto the output stream OS. Okay, and then it returns OS. Okay, so here your output stream can be C out. Okay, C out or anything else that you have defined as a reference to C out, because you can't define your output stream objects. Okay, you can only define references to them. That is a later topic that we would discuss. It's not very much related right now. So basically, it's copying. It is writing the value of S into your output stream. Okay. So if, for example, we consider the output stream to be cout. Okay. So what does cout mean? Cout means your console output. Okay. So whatever your output is being printed on your console. So cout is just an object of your OStream class. Okay. And this is what an overloader constructor is. Okay. We would come to constructor overloading after some time, but for now I'm just making you a bit familiar with the things. Okay, so what this operator does is that it copies the value of the string. Okay, sorry, it writes your string onto your output string, that is cout. Okay, so whatever there is in the string, it would be printed on this screen. Okay, so next we have your input stream, and then your string. So in this case, it's reading your white space separated string from is into the string is. Okay, so a typical example of your input stream object is your cn. Okay, so cn means your console input, whatever you are typing from your keyboard. So cns means that you are accepting some value from the keyboard that is being inserted into your s. Okay, into your s string. Okay, and it is also returning is. Okay, so basically returning is and os means that it is returning the particular state of that object. Okay, we would discuss about it later in much more detail. After this we have your getLine function. Okay, so getLine function, this is very much similar to your cn. Just the exception here is that there is also presence of delimiter character at the end. It has not been shown over here, but you can write a delimiter character at the end also over here. So by default, your delimiter character is your /n. Okay, the new line character. So whenever you would press an enter, uh, then it would not be read, and the value to the string, it would be copied. Okay, so get line iss, so this reads a line of input from is into s, and it also returns is. Okay, after this we move to your empty function. So this function checks whether the string is empty or not. S.empty function. Your size function, this also checks the size. This checks the size of your string. Then s subscript n, so it returns a reference to the character at position n in s. So whatever character is present in position n, that is returned. So this is very much like your arrays. Okay, so if you want to get the first character of the string, you just have to write s subscript 0. After this we have your s1 plus s2. Okay, so this returns a string that is concatenation of s1 and s2. Okay, so if you have a not a plus b, if you have some string, that has value a, okay, and you write another string with value b, and then you just add them up, then it would just produce a. Okay, so this is concatenation of the two strings. Then s1 equal to s2, this is your assignment. Okay, so you can assign the value of one string into another. Okay, so it also replaces the characters in s1 with a copy of s2. Okay, if s1 is already filled, then also it would copy the value of s2. Then we have your equivalent operations, your negation operation, and these relational operations. So equivalent operation checks for the equality of the strings, whether these have the same characters, and your equality, it is case sensitive. Then we have your relational operators. These check the string one by one. Okay, so so your relational operators, these would just check for your less than or greater than. Okay, so it is basically a character based comparison. So if and the comparison is case sensitive. Okay, so if you have written like hello, okay, and then you write your hello word. Okay, so first of all it would compare each character. Okay, so all the characters till this are equal. Then there is a space, and we have this additional character. Okay, so since the size of this character is more, it is greater than your hello. Okay, so this is the basic of comparison. If we had written hello and then your ABC, okay, then it would have compared the first character A and H. Okay, so which one of them is greater? So H is greater. So it would say that hello word is greater than ABC. So this is the basis of comparison of your two strings. Okay, so next we would move to your reading and writing strings. So there are two methods of reading and writing. There are two methods of reading your strings. First is your CN, and the second one is your getLine. Okay, CN and getLine. And the method for writing your strings is cout. Using cout, you can write your string. Okay, so you must be knowing about this if you have done C before, not C, some basic C++ before. So I would just focus on some interesting things regarding this. Okay, so if you want to read an unknown number of strings using CN, then you can use your while loop and write like this while CN word, and then whatever you have to write inside it. Okay, so this is a very much interesting way of doing this. And how you would stop the input is by pressing Control plus Z. Okay, so by this method, you can read an unknown number of strings using CN. And similarly, this is happening because your CN object, when this operator is applied on it, and uh, then in that case, it is returning an input stream object. Okay, so this expression, the validity of this expression is being checked. Okay, so if this is valid, then the loop will proceed, and it would take the input, and the statements below would be executed. But if you hit Control Z, then it becomes invalid, and the output is stopped over there. And similarly, you can apply the same thing to your getLine function. GetLine is it also returns an input stream object, and whose validity is tested, and then the consecutive statement are executed. Okay, so this is an interesting thing over here. So next we move to your string size type. Okay, so for storing the size of your strings, there is a different type defined in the string class, which is your string scope resolution operator size type. Okay, so this is capable of storing your size of the. So whenever you are calling something like s dot size function, then the value it would be returning would be of the type string size type. Okay, so in that cases, you can use auto, or even if you use integer or long or something like that, the conversion is very much automatic, so the difference is not much felt. But if you want to use this specific type, then either you can mention it, or you can write auto something your s1 equal to s dot size function. Okay, so you can do this, or you can replace this auto by your string size type also. Okay, so the size function returns your size type. And whenever you are writing something within your subscripts also, then this type is expected to be a size type. Although if you write integer or or long integer or something like that, then also there is type conversion, and so the difference is not much great. Okay, so after this, this is done, this is done, this is also done. So after this, we move to your adding strings, literals and strings. Okay, so this is also an interesting thing. So first of all, you can add two strings directly. Okay, we have seen here also s1 plus s2. We can add directly, and there is a concatenation. But in the case of literals, it is different. Okay, so let me show you with the code. Okay, so here it is. So we have defined two strings s1 and s2, hello and word, and then we are writing s4 equal to s1 plus this string. Okay, this is a string literal. So this is a valid case because we have a string type and your literal. Okay, so if any of the uh, the types that we are operating on, so if any of the operands is a string type and the other is a literal, then this operation, it is perfectly valid. Okay, so the plus operation is perfectly valid if any one of these is at least a string. Okay, so if both are literals, like in this case, okay, so then this operation is not valid. So we like this example also. This is more basic. Okay, so this is not valid because both of them are literals. But in this case, it would be valid because we have your s1 plus then a literal. Okay, so what the compiler will do, it would make brackets like this. Okay, so these brackets are made. Then when the addition is performed, then this is a string in that case. Then we are again adding a string with a literal. Okay, so this is perfectly valid. But then we move to the below example. In this case, the compiler would make brackets like this. Okay, so we are trying to add a literal with a literal. So this is an error. Okay, so the compiler will not proceed, and it would show an error that string literals can't be added. Okay, so this was important thing. After this, we have done this. Now we would see dealing of with character in a string. Okay, so these are some important functions. Okay, so you just need to see them, and I would tell you which of them are more important. So you don't need to remember all of these. Okay, you can find these. You can refer to these in any book at any time. Okay, so first of all is your is alnum. So it checks whether the character is an alphabet or a numerical. Then is alpha. Okay, so you can just see them in your book. There's nothing much to explain over there. Okay, and it's not that much important. I would tell you the important functions is alnum, is alpha. These are important. Is lower is important. Your two lower and two upper, these are also important. So these are the ones that you would be using more frequently compared to the others. So I have just marked them. Okay, is upper also. So rest of them you can see in any reference and at any time, so I would not be discussing those. Okay, so there is a note about header here, that if you want to use all these functions, okay, so in that case you have to include C string header. Okay, so you have to write hash include C string, not your hash include string dot h. So the reason behind this is that your string header, this belongs to your C language. Okay, so and if anything is added, if a C is added to any of your C header, then it means that some functionality has been added to C++, and it is a more refreshed version. Okay, so in case of your math function, math header file, also you would be seeing that that math .h exists in your C language, but in C++, you would write C math. Okay, so whatever you have learned in C, just add this extra C in front of that for getting your additional functionalities in C++. Okay, so this was your note. Then we would see this. Okay, processing every character on in your range based for loops. Okay, so if this is a new feature which has been added to your C++ level. Okay, so this feature says this features allows the processing of every character in your string or any container. Okay, you would be I would talk about the containers later in later videos, like 6-7 videos later. So basically, this range based for loops, it can be used in cases where we have your container or something like string. Okay, so in those cases, for processing each and every element of that type, we can use range based for loops. Okay, so I would show you the syntax for this. So we just write for your declaration. Okay, declaration means that you are declaring a variable over here, like a variable which would store the value of each of the elements of whatever you are going to write in this expression. Okay, so we would see an example on your string. Okay, so this is a string some string. Okay, so we write your range based for loop like this: for auto C, str, cout, cend. So what this range based for loop is doing is that it is copying each value of the element in the string to your C. Okay, and we have mentioned auto over here. So auto would automatically guess what type is your element, each element in the string. Okay, so it is char type, so auto would become char over here. Okay, so this is a preferred way of writing range for loops, range for loop, instead of your regular char or that thing. Okay, so you can type char also, but auto is the way we are generally using this thing, and you would see that further in your vectors and container types also. Okay, so we are done with this range based for loops. So I would just summarize the range based for loop. It is processing each and every character of the string. Okay, so each and every character C, it is processing of the string. Okay, so another way of processing. Okay, so this was processing every character, but what if you want to just focus on one individual character? So in that case, you can use your subscript operator over there. Okay, so as subscript n, so it would return a reference to a character at position n. Okay, so one important thing to note about your subscript is that the subscripts are not checked. Okay, so if for example you have written something like hello. Okay, so 1 2 3 4 5, so there are 5 words in hello. Okay, so and if you write s5. Okay, so S5 if you write and if you do C out, then it would be an error. Okay, because your uh, this thing is subscripting starts from 0 to 4. Okay, 0 to 4, the subscripting is there 0 1 2 3 4. Okay, so if you write S5, then it would just it would not be able to identify this error. This is not checked actually. Okay, so this would be something like a runtime error, or it would the program would run, but the compiler, it would not be able to detect this thing, that the subscript is exceeding the value it is supposed to take. Okay, so you have to be careful about using these subscripts. Okay, so in this case, in the case of hello, you can just use subscripts from 0 to 4, not your 5. Okay, so the topic of strings is completed. Next, we move on to your vector types. So this is something which has become very much common these days, and arrays, these are not at all used. Okay, so once you have learned about vectors, then you would rarely be looking towards array. So what exactly are your vectors? Okay, so what exactly these vectors are? So vectors are your container types. Okay, so these are containers which contain values. Okay, and a vector is a template. Okay, so vector is a template, and what exactly we mean by template? First we have to question that. So a template is just an instruction which is given to a compiler. A template is neither a function, okay, nor a template is a class. Okay, it is neither a function nor a class. It's just an instruction. Okay, it's a instruction which is given to the computer on the basis of which your uh, code will run. Okay, so a template is just an instruction. So since it's an instruction, it can take a variable data type. Okay, so a template, it can take any type of data type. So you are just talking about your specific set of methods that you have to follow, and the data type, it would be inserted at a later stage. Okay, so a template, it can be either a function template, or it can be a class template. Okay, so we would be talking about templates at a very later stage, when we have some experience with C++. But it does not in any sense stop us from using and implementing it. Okay, so I would just be repeating. A template is just an instruction. Okay, and it can take your variable data. Okay, so a template also enforces your GPP. Okay, it enforces the generic programming paradigm. So this paradigm, it relies more on your ways to accomplish the task, rather than depending on what the data type is or something like that. For example, if we want to sort things, okay, so we would just give an algorithm for sort, and then we don't have to care what the type of data we are dealing with. Okay, so this sort, it would be equally applicable to your characters, equally applicable to your integers, long, float, or anything like that. Okay, so we can make a template of sort, and then we can use variable data type in that. Okay, so now we formally define your vector. So a vector is a container uh, which stores values of variable data types. Okay, so the data types that vector can store, it is not fixed. Okay, so this is what vector is, and for using vector you have to include #include vector. Okay, so the header file in this case is your vector. Okay, so vector is the header file. So now we will see the ways in which you would initialize your vector. So a vector, it is written just like this: vector, okay, then your variable type, and then the variable name. Okay, so it has been written over here: vector, the variable type, and then the variable name. Okay, so we would be talking about the ways in which we can initialize the vector. So first of all, the basic way is your default initialization. So in this case, the vector is empty. Okay, so one more thing I wanted to mention about vector is that vector has a variable size. Okay, so the elements in the vector, it can increase with time. Okay, so if we just compare vectors versus your arrays, then your array is something which is statically allocated. Okay, so before the compilation, we know what the size of an array is going to be, but in the case of vector, we don't know the size, so this is dynamically allocated. Okay, so the size can increase for vector during your runtime also. So now we come to the initialization part. So when we are writing something like vector, your variable type, and then v1. So in this case, we are creating a vector which can hold a variable type of t, uh, and has a variable name v1 and is empty. Okay, so this vector is initially empty. It contains no elements. Okay, the size can of course grow after you add elements dynamically during the runtime. Okay, so next we see the second declaration: vector t v2 v1. So you can draw comparison with the ways to initialize the string over here also. Okay, so this you had also seen before in your string initialization. We are just copying the value of v1 into v2. Okay, so this is pretty similar to that. Then you can assign a vector to another vector. Okay, so this you have also seen in your string. Okay, so after this, you can also uh, initialize a vector with a vector with n elements having value val. Okay, so you can do this also, and then you can create a vector which has n copies of your value initialized objects. Okay, so after this, you can also list initialize the vectors using your curly braces. Okay, so you have written this, so it means the vector is storing these values a, b, c, and so on. Okay, and then you can also write equal to instead of doing this. Okay, so we have talked about four methods: your default initialization, your list initialization. Okay, so this was your default initialization. Then the list initialization was this and this. Your value initialization means that you are just giving the size to the vector. Okay, so this is the value initialization. You are just giving the size to the vector, and then it is value initializing those things. Value initializing means that it is calling the default constructor in that case. Okay, in the case of integer, long, and those things, the vector would initialize zero value, uh, but in the case of your strings and those things, the vector would call the default constructor. Okay, so this is your value initialization, and then finally you have your copy initialization. Okay, so these are just copy initialization. Okay, so these are the four methods to initialize your vector. So there is some confusion usually between your value initialization and your list initialization, because these look very much similar. Okay, so let me just show you a code over here. Okay, so if you are writing like this, vector int v110. Okay, so and you are using parentheses, so this means your value initialization. Okay, so we would create a vector with 10 elements, all of which are value initialized. Okay, then we have your list initialization. We are writing v2 curly braces 10. Okay, so in this case an element is copied to the v2 vector, and which has your value 10. Okay, then this also is similar: v3 10 comma 1, 10 elements each having value 1, and then this is your list initialization. Okay, so in this case 10 and 1, these are copied into the vector. Okay, so this is list. When you are using curly braces, then it's list initialization. When you are using your parentheses, then in that case it is value initialization. So this thing is something which needs to be taken care of. Okay, so next we move on to your vector operations. Okay, so these are just some operations that you have to memorize, and these are very much frequently used, so it won't be so much tough to remember these. Okay, and you can draw a parallel between the vector operations and your string operations also. So for example, your empty function and your size functions. Okay, so these are very much similar to the functions that we discussed on strings. Okay, then we have this new function v dot pushback t. So this is very much important. Okay, and you must remember this all the time. Okay, so v dot pushback function, it helps in the dynamic, in growing the vector dynamically. Okay, so if you have defined a vector v. Okay, and so if you define vector v, then in this case it is empty. Okay, and say you want to insert a value of 5 in this vector. Okay, so in this case you have to write v dot push back, sorry, push back 5. Okay, uh, wait 1 second, you have to write this. Okay, so this is an important function. Okay, so 5, the value of 5 would be added at the back of the container. Okay, so the container is initially empty, so 5 would become your first element. Okay, so basically there are two types of in which you can add values to your vector. First of all, one is that you can already define a vector which has a size something like 10, and then you are just using subscripting over there v1 equal to, and then you are adding the value. And the second way is that you are just default initializing a vector, and then you are using the pushback functions to dynamically add memory to dynamically add values to the vector. Okay, so these are the two methods. You can also add more elements at the back of these 10 elements anytime by using your pushback functions. Okay, so uh, people who are new to the C++ language, they usually prefer this one, but it has been written at many places that this uh, this method or this way of using pushback functions, it is more effective, and it is a more efficient way of adding elements rather than using your subscript operator. Okay, so this way of adding elements using pushback functions, it would lead to a better performance. Okay, so just like your strings, over here also you can dereference your elements in the vector by using the subscript operator. Okay, so this is also similar to your strings. Then your assignment, also similar to the string. You can assign a vector to another vector, and this would just override this existing vector. Okay, uh, then you can do a list initialization here. Okay, so this will also just override the existing vector, whatever elements there are. Okay, then there is your comparison operation, uh, your negation of comparison, checking the equality operations. Okay, so this checks whether the vector are equal, this checks whether they are not equal, and then your usual comparison operation. So the comparison operations, these would work element wise. So these would follow your dictionary ordering. So v0 would be compared to, for example, if we have two vectors v1 and v2, then first of all v10, it would be compared to your v20. Okay, and then we would check which of them is greater, and then we would be following the dictionary ordering like 0 1 2 3 4, and then checking simultaneously here also. And at any stage, if one element is greater than the other, then that vector would be set to be greater than the second vector. Okay, so v1 would be greater than v2 if v10 is greater than v20, or if in case these both are equal, then the next one would be checked, and then accordingly we would decide about that. Okay, so you are done with your vector operations. Now we will see the range based loops, and this time with reference. Okay, so as I told you before also, your range based loops, these can be used to iterate over anything that stores values. Okay, so vector is a container. It stores values. So we can use range based loops in vectors, just like we did in your strings. Okay, so you could have write for auto I v, and then whatever C out I, and those things. So I just want to demonstrate the this reference thing. So that's why I've taken this. That is also perfectly valid for auto I v, and then C out I, whatever you are doing. But if you just write for auto I v and then you are writing this I into equal to I, so you want to you want that each element is squared, but this would not happen. Okay, so you want that each element of this vector is squared, but this is not what is going to happen until you use a reference over it. Okay, so what happens in case of a reference is that you are actually referring to each element of the vector. Okay, so you have full rights to change and modify that element. Okay, so this is something you need to be careful about, that you must use references. Okay, to change the values of the elements in any type of container or something that can be iterated upon. Okay, okay, so after this we are done with this, and there is an important note over here, that you are subscripting, it is not going to add values. Okay, so if you are thinking the size of your vector is the size of the vector is something like 3. Okay, and you want to add you want to add an element at the 10th position, and you are just assigning any value over it, like v10 equal to 1. So this is wrong. Okay, so or else if you are doing something like v3 equal to 1, expecting that the fourth element, it would be assigned a value of 1, then you are wrong in this case. Okay, so this is not the correct way of adding values to the vector. The only correct way is by using the pushback function. Okay, so if the size of the vector is less, then the only way to increase its size is by using the pushback functions and not your subscript operators. Okay, so this must be clear, that the subscript operator, it can't be used any case for adding your elements to the vector. Okay, so this is done. Okay, now we would move to an important concept, your iterators. Okay, so iterator, it is a very much important concept, and the clarity regarding this should be very much high. Okay, so first of all, we would define what exactly these are. Okay, so iterators, these are very much synonymous with your pointers. Okay, so iterators can be used to fetch an element from any container. Okay, so since a vector is a container, it also has iterators. Okay, so iterators, these you can visualize like pointers. Okay, so each container would have iterators, and those iterators, these provide a more convenient way than your pointers in accessing each of the elements of your iterator of your container. Okay, so in this regard, we would be talking just about vectors, and many people think that if we have your dereferencing thing over here. Okay, we can use the subscript operator, and then we won't have to use the iterator anytime. We would just use your for loop, and we would be able to increment over all the elements. Okay, So many people have that feeling. That is one of the right ways, but that won't happen in the case of other containers. Like if you would see later your map and set containers, then in that case you can't use subscripting over there. Okay, so subscripting is something which is special to your vector container only. Okay, so only your vector container, it can use subscripting to fetch your elements at any position. Okay, so the basic definition is just that uh, it is something which is used to fetch an element of your container. Okay, so we would be talking about iterators in regard to vector array. So first of all, we would see your standard container iterator operations. Okay, so much like your pointers, star iter, this is one of the operation. So this returns a reference to your element denoted by the iterator iter. Okay, so I'm just repeating the thing written over here, but there is nothing more I can say about this. Okay, uh, this is where it starts and this is where it ends. Okay, so this this is an iterator, it is very much similar to your pointer. Okay, so just like your operation on the pointer star iter, it would return a reference to the element towards which is being denoted by iter. Okay, so just like your pointer also, you can use your dereference operator over here. Okay, so iter your mem, this arrow, this can be used to access the uh, elements that are being denoted by iter. Okay, so this is your equivalent to star iter dot mem. Okay, so these parentheses, these are important because dot has a higher precedence than your star, and if you just write star iter dot mem. Okay, so in this case it's going to assume that mem is a pointer and you are trying to dereference that, and iter is just your object. Okay, so this definition, it is equivalent to your star iter dot mem. Okay, then we have your usual incrementation operators and decrementation operation over here, and then we can compare two iterators of the same similar types. Okay, uh, their equality and their inequality both can be compared. So you must remember that there is no less than operation or no less than equal to, greater than, or greater than equal to operation. Okay, so relational operations are missing from your iterators, and these must not be used. Okay, if you use them, it is an error. Okay, so just these comparison operations are valid for iterators, and you can just increment an iterator and decrement an iterator, and nothing more than that. Okay, there are some specialized versions of these operations for vectors and strings, which we would be discussing shortly. Okay, so let me just check first. Okay, so now we will see what are your iterator types. Okay, so the precise type of an iterator, it is not known. Okay, so instead the library for each of your container has predefined iterators. Okay, so if you see the vector, then in this case they have defined iterator type in your vector library only. Okay, so this iterator type, it has already been defined, and whenever you want to declare an iterator, then you have to use this type. Okay, so vector int scope resolution iterator you would use to declare your iterator. Okay, iterator IT. And if you are using some constant if you are using some constant iterators, then in that case also there is a specialized version. So this iterator, it can read, but it won't write to the elements. Okay, so this is a constant iterator. Okay, so in the case of your constant data types, this iterator would automatically be called if you write something like auto it3 equal to uh, that value, whatever the function is returned. Okay, so we would see those functions also shortly right now. Okay, so in most cases you would just be using auto. Okay, so you don't need to worry about this thing. Okay, so next we see the begin and your end operations. So begin and end operations, these are important. Okay, so the your begin operation, it it would return an iterator to the first element of your vector. Okay, so begin function is very much general, and it is used in your containers also. So the begin function, it returns an iterator to the first element of your container. Okay, so the iterator returned has a type vector int uh, your iterator, and the if you use cv.begin function, then in that case it would return a constant iterator. Okay, so in that case you won't be able to change the value of your element. Okay, so that is something which must be noted. Then you have your end function. Okay, so this end function, it is also very much important. These begin and end functions you would be encountering very much while dealing with your container types. Okay, so you should be very much familiar with them, and these are something which you must note, and it must be in your mind. Okay, so you must not forget your begin and end functions anytime. So the end function, it would return an iterator just after the last element of the container. Okay, so for example, if the size of the container is say 1, then the end function, it would return an element at position 1 plus 1. Okay, 2. Okay, so I would just draw this to clarify. Okay, so if this is your container, then the begin function, it would point to this element, but the end function, it would point the end function, it would sorry, the begin function, it would return an iterator to the first element of the container, but the end function, it would return an iterator just past the last element of this container. Okay, so the iterator is something over here. Okay, so this is a bit confusing, but it is just pointing just after this. Okay, so this is something which you must keep in mind, and must be careful. It is not pointing to the last element. Okay, so it is not pointing to the last element, but past the last element. Okay, so This is something to be noted. Okay, so similar to your begin function, uh, we can uh, we can have your constant C end function. Oh, I just did a bit mistake over here. Note this thing that CV, it is a constant vector over here. Okay, so that's why the iterator that is being returned by CV dot begin function, it is a constant iterator. You can also write auto it 4 then equal to your v dot c begin function for getting a constant iterator. Okay, so this can also be used for getting a constant iterator on a vector which doesn't have constant values. Okay, and similar story goes for the end function. You can use the end function for getting constant iterator on a vector which doesn't have a constant data type value. Okay, and if this vector is storing constant values, then in that case the end function, it would be returning the constant iterator just like it was returning in this case. Okay, so next we have combining dereferences and member access. Okay, so I have talked about this before also. Instead of writing star it dot empty function, okay, instead of dereferencing this first and then using the associated functions related to this, we can just use this operator. Okay, so this arrow operator, it can be used instead of your dereferencing operator for dereferencing this. Okay, so it in this case, this is an iterator type. This is not your object. So this iterator type and then the arrow operator, it can be used for accessing the functions of uh, your object. Okay, so we are done with this. Okay, so we are done with the iterator part. Oh, no, wait, we have then your vector operations that invalidate iterators. Okay, so while you are for example, if you have assigned an iterator, like if you have assigned an iterator like auto it equal to v dot begin function. Okay, so and then you are uh, expanding this vector by adding elements, like you are doing v dot pushback and you are adding some values to this vector. So in this case, this iterator, it would become invalidated. Okay, so this is happening because the size of your vector, it has increased. Okay, so the iterator, it would be invalidated if the size has increased. This would more be in the case of v dot end function. Okay, v dot end function, it is much more logical to describe that the position has changed and those things, but it is also equally valid to the v dot begin function. Okay, so the iterator value is invalidated in case the size uh, has been changed during the program run. Okay, so this is something which is important. And lastly, we have your iterator arithmetics for vectors and strings. So as I said, some additional operations, these are allowed for your vectors and strings. So you can just add an integer value to your iterator or subtract an integer value to the iterator, or do like this itr plus equal to n. Okay, so you are assigning a value to an iterator which is not allowed. Okay, in reality this is not allowed. Okay, assignment is in that form that you are adding or subtracting something from this same iterator only. Okay, it's not that you are assigning one iterator to the other one. Okay, that is still not correct. Okay, so and then you can subtract two iterators in the case of vectors and strings, and in this case it would just return an iterator of the same type. Okay, so if you are subtracting two vector iterators, then in that case a vector iterator would be returned, and if you are subtracting two string iterators, then a string iterator is returned. And then finally the relational operators, these are valid. Okay, so these relational operators on iterators, these are valid in the case of your vectors and strings. Okay, for your usual containers, the relational operators, these are not valid. Okay, so one iterator, it is less than the other one if it refers to an element that appears in the container before the one referred by the other iterator. So this is pretty straightforward. Okay, so the iterator must denote elements in of one past the end of the same container. Okay, so the relational operators, these are very much straightforward in this case. Okay, so this thing is completed. Now next we move to your array topic. Okay, so this is going to be complex, and not so much complex, but it is going to be a bit more complex than the string and vectors we have been dealing with, and those are so much easy and straightforward things. Okay, so now we would be moving to arrays. Okay, so first of all we would start by defining your arrays. Okay, so the definition of arrays, many of you would already be knowing that the array, it is a data structure. Okay, data structure which is used to hold your which is used to hold your data types. Okay, so any data type can define an array, and an array has a fixed size. Okay, so the size of an array is fixed, and it can't grow once the size has been fixed. Okay, so that is the basic definition. uh, Sometimes the arrays, they offer a better performance compared to your vector, but the trade-off is because of the reduced flexibility. In the case of array, the size has been fixed, and it can't do it, right? Okay, so I won't be discussing very much uh, like from starting about arrays. Okay, so since you have some programming knowledge, you must know what arrays are. So we would just focus on the complicated part, and we would try to understand complicated array declarations. Okay, so uh, we would take some examples for doing this. Whenever you are dealing with some complicated situation in case of array, the best approach is moving from in to out. Okay, so we would see in the uh, following examples. Okay, so first of all, let's see this example. So in this case, first we focus on your variable name. Okay, so we see the variable name is ptrs, and then we move a bit out. Okay, so what do we see? We see a star. A star means this is a pointer to your integer, and then we see that the number of pointers, these are 10. Okay, so this is an array of 10 pointers. Okay, so pretty straightforward. After this we move to our references. So just like the previous example, uh, this was supposed to be an array of references. Okay, but we can't have arrays of references. Okay, so This is basically because if you are having an array of references, then you must be knowing that an array is more or less treated like a pointer. Okay. If you have read C language, then you must be knowing this thing, that an array is treated like a pointer. Okay. So if you are saying that we have an array of references, then in that case you are saying that we have a pointer which is pointing to a reference. Okay. And since a reference is not an object, so that's why you can't have an array of references. Okay. So that's why the pointer won't point to the reference. Okay. So that's the reason that array of references is not allowed. So this is a pretty interesting thing, and uh, you should know this thing. Okay. So and talking about reading these arrays, the approach of reading inside out, it was for more complicated declarations. In this case, if you just read from right to left, also in this case you have to just read from right to left. Okay. So there are no parentheses like in this example, so that's why an inside out approach is not required here. Okay. So if you have to read this, then you would be reading like from right to left. So this is an array. Okay. An array having a size 10. And what is the name of this array? Refs. Okay. And then you get to the type. Okay. So this is going to be an array of references. Okay. And uh, what would be it be what data type would it be referring to? So it could be an integer. Okay. So this is the correct way of writing. Next, we move on to even more complicated declarations in which you have your parentheses. So in the case of your parentheses, uh, you would be reading these definitions inside out. Okay. So so first of all, you see the name of this variable type is PRA. Okay. Then you see this star, and you get to know that the variable type it is going to a point. Okay. Then you move out. Okay. When you move out, you would see this, that it is an integer. Okay. And it is having a base type 10. Okay. So it implies that this is PRA, it is a pointer which is pointing to an array having size 10. Okay. So this array is an array of 10 integers. Okay. So this pointer, it can be used to point to other arrays. Okay. So having a base type of 10 means that whenever you are now going to do incrementations in this array, then the incrementations would be in the size of 10. Okay. So if you would be doing PRA plus plus, then it won't be that it would point to your second element of that. Usually, if you are a bit familiar with this thing, if you write int star p equal to your sum array, okay, whatever array you have defined earlier, then this p, it would point to the first element of the array. And then if there is some incrementation, then the second element of the array, the third element of the array, and so on, it would point like this. Okay. So the reason for that is that it has a base type of only int. Okay. So a base type of only int implies that the incrementation would be with regard to just int. Okay. So the it would point to second element, third element, and so on. Okay. So this is something you must know. And then if the base type is changed to your 10, okay, so then in that case the incrementation would be uh, with reference to this base type. Okay, so there would be 10 implementations instead of just one. Okay, so this is an important thing. And this would be more useful in the concept of your multi-dimensional arrays. Okay, so when we will reach there, then I would tell you this again. Okay, so next we move on to this again. We would read it inside out. So this is your variable name. You see the ampersand, you get to know that this whole is going to be reference. Okay, so now you move outside, and then you see that the variable type is going to be an integer, which is going to have a base of 10. Okay, so now this variable, this can be used to point to other arrays, not point, to refer to other arrays. Okay, so ref can be used as a reference name for other arrays. Okay, after this we would see this. Okay, so uh, first of all, focus on the variable name. You see the ampersand sign, you get to know this is a reference. Okay, then you move out. Okay, this is very much complex. Then you move out and you see that the data type is int star. Okay, and what is the size? It is 10. So you have an array of uh, a reference which is pointing to an array of 10 pointers. Okay, so this is an array of 10 pointers to which this reference would be pointing to. So this is done. Okay, so anything else we have here? Also, your this parallelism between the pointers and arrays, it is much more evident when you use your auto type. Okay, so when you use your auto type for seeing what is the type of the array, then what is returned is an int star. Okay, so an int star is returned. So you can draw an inference from there that an array is essentially converted to a pointer by the compiler. Okay, so these two declarations, int star p equal to ampersand nums 0, in this case you are pointing to the first element, and int star p2 equal to nums, these two are equal. Okay, so whenever you are writing this, you are just denoting the first a pointer to the first element of the array. Okay, so this is done. And then if you do something like this, ia2 equal to 42, then it would show an error because ia2, it is a point. Okay, but the case is a bit different in the in declare type. Okay, so in the case of declare type, if you use declare type, then this becomes an array only. Okay, so it becomes an array, and it becomes an array, and it can't be used as a pointer there. Okay, so you can just use the subscripting over here to denote, to assign the values, but you can't use it as a pointer. Okay, so this is done. Let me see. Okay, now we would see we have completed with this pointers and arrays. Wait, pointers and arrays, we are done with this thing. Then we would see how to access the elements of an array. Okay, so subscripts is pretty basic. Okay, so you can use subscripts to access an array, dereference an element at a particular position, uh, or you can use the range for loops, like we have discussed for your vectors and strings. Similarly, these can be used for array also. For example, if you just define something like int a 5 and something you declare, okay, you initialize this thing and or you define this thing, whatever, then you can use your range for loops to access the elements. Okay, so let me show you this in more detail. Okay, so where is it? Okay, so I have not written any code over here, but you can just like a vector, you can just write for auto I, whatever your array is, and then see out your I and those things. Okay, and of course you can use ampersand over here for your values. Okay, for changing the values and those stuff. So this is done. uh, Next we move to this important. Okay, I haven't talked about size t. So whenever you are writing something in your subscripts, so the compiler assumes that you are using the size, the variable type which is having the variable which is having the variable type size t. Okay, so size t, it is defined in cstd def. Okay, so this is something you must know. Okay, even if you use int long and those things, as I have already mentioned, those things would automatically be converted, so you don't need to worry much about that. Okay, so but by default the compiler assumes that you are using your size t data type. So next, moving on to this. Okay, so pointers are iterators. Okay, so you must know that pointers can show all the behaviors the iterators can show. Okay, with arrays, pointers can show all the behavior like an iterator. An iterator would not be defined for your usual C style array. Okay, there is another type of array that we would be discussing later when we would be talking about containers. But in case of C style arrays, there are no iterators because this is not a container. Okay, so in this case you are just limited to your pointers. Okay, so you can use pointers just like iterators. Okay, so in star p equal to r, then it would be pointing to the first element, and if you use in star e equal to ampersand r10, then it would be pointing to your last to the one past the last element of the array. Okay, so just like the end function, this is behaving like your end function in container, and this is behaving like your begin function in the container. Okay, uh, okay, although there are the library and begin and end functions also specifically defined for your arrays, but still you can use these for feeling like you have iterators in the case of arrays. Okay, so the begin and end functions, these would behave just like in case of your vectors. Okay, and if in the case of vectors, since it is a container type and it is a template, the function is we can write v dot begin function and something like that, and but it is the begin function, it is not defined in your arrays. Okay, so we have a begin function which has been created, and This can be used in case of arrays to get your first element, and the end function can be used to get one past the last. Okay, so this has been discussed. And one thing also, you need to include the iterator header file for using your begin functions and the end functions, as the type returned by them, it would be an iterator. Okay, so we are done with this. Next, oh, what the hell? Okay, next we would see the difference between your strings and the C style strings. Okay, so the strings are what are in the newer versions. So in case of C style strings, it's absolutely illegal to use your relational operators, because the C style strings, first of all, you must know what it is. Like for example, we have your char string, and you are writing something like apple. Okay, this is a typical example of C style string. So in a C style string, you can't just compare two strings. So S1 is less than S2 or whatever like this. You can't do in the case of C style strings. Okay, so this is invalid, as in this case you would just be comparing the addresses of two strings, which is not a defined operation in case of pointers. Okay, and secondly, S1 plus S2, it is illogical and it is not defined. Okay, concatenation is not defined in the case of C section. Okay, so this is also done. Now mixing library and C type strings. Okay, so these are the functions which are available for C type strings. You can get the string lengths, you can compare two strings, you can concatenate two strings, and you can copy two strings. Okay, so these functions are pretty basic, and you can refer to them in any book or at any site. Okay, so I'm not going to discuss these things over. So mixing your library type strings and the C type strings. Okay, so if you are you want to initialize a C style string with a string, okay, the modern string used in C++, then you must use s dot cstr function. Okay, so this is a function. So this would convert your usual string into a C style string, and then it would copy into that. Okay, and the type returned by this is constant character. Okay, so since the type return is constant character, that's why we have mentioned this over. So it would also include the null character, and this function, it ensures the backward compatibility with your C style strings. Okay, so this is done. Okay, lot of things are left still. So now how to use an array to initialize a vector. Okay, so you can use an array to initialize a vector, but not vice versa. Okay, so you can't use a vector to initialize an array, but an array can be used for initialization of your vector. Okay, so let's just see the code. Okay, so if you have some array given like this entire, then you can use your begin function and your end function for initializing the vector. Okay, so just write your begin entire and end entire for copying the whole array into the vector. Okay, so this is a pretty standard way of copying values to an array, and it would become much more clearer when you will see the container types. Okay, so this is done for now. Okay, so if you want to copy some specific values, then in that case you can do it like this. Entire it is the name of your array, and +1 means the first element, entire +4 means your fourth element, and in this way you can copy it. Okay, so this is also done. Now we would move to your multi-dimensional array. Okay, so this is somewhat complex. First of all, we would try to understand the declaration of the multi-dimensional array. So if you have something, let's not take something this much complicated. First we would start with some easy example. Supposedly if you have something written like this entire thing, okay, and then 20. So in this case, how would you read this thing? So first of all, you would read r. Okay, so r is a variable name, and then you go to your left. Okay, so to your right, sorry. So you see this has a size of 10. Okay, so r, it is you get to know r is an array which has a size of 10. Now moving outwards, when you move outwards, you realize that this array, it is an array of this is an array of size 10, and this is going to have a base type of 20. Okay, so the integer values that are going to be entered, these are going to have a base type of 20. Okay, so most of you would be already familiar with multi-dimensional arrays, I think. These are just something used to represent your matrices and those things, but in actuality, these are just linear things, and then there are divisions over there. Okay, so it is just an array which would have 10 divisions, each having 20 integers. Okay, so this is your basic thing. Okay, so if you move on to your more complicated multi-dimensional arrays, then you would see that the array would be consisting of 30 elements, each being divided into your 20 parts, and these 20 parts, these would be further divided into your 10 parts. Okay, so these 10 parts, these are going to have 20 parts, and each 20 part is going to have 30 parts. Okay, so this is your basic way of understanding this. Okay, so let me just draw a diagram. Things would be more clear. Okay, so if supposedly say you have some array like int r 2 and 4. Okay, so then in this case, you are going to have total 8 elements. Okay, 1 2 3 4 5 6 7 and 8. Okay, so each this whole thing is partitioned into two parts. Okay, so 1 and your 2. Okay, and each part, it is going to have 4 integers. Okay, so it's the same logic you can extend to your three-dimensional array also. Say if I would have written something like 1 over here, then it would have implied bigger a bigger part of this thing. Okay, so this whole uh, uh, this whole thing is containing inside it two smaller blocks, and these two smaller blocks are containing inside it 4 integer values. Okay, so this is your multi-dimensional array. So now we would see your initialization of multi-dimensional arrays. Then in this case, if you just want to initialize all the values to 0, then you can use this list initialization. Okay, and if you write 0 here, then all the elements of the array, these would automatically be initialized. with 0. Okay, so moving on, next we have done initializing, then your usual subscripting for getting the values of the multi-dimensional array. So you must be familiar with this if you have done some language, so I would be skipping this. Okay, now I would move on to your more important part, that is using range for accessing the values of the arrays. Okay, for multi-dimensional array. Okay, so one thing also I wanted to mention earlier was that you can have vectors of vector. Okay, so if you write something like this, vector and then vector int, vector your vector int. Okay, so in this case also, sorry, I'm not able to write properly. So in this case also, this is perfectly valid thing, and this essentially implies a multi-dimensional array only. Okay, so the way you can visualize it is like a multi-dimensional array. So this was something I wanted to mention earlier. uh, okay, so now we would be using range for accessing the elements of your multi-dimensional array. So for doing this, you one thing, okay, so first let me show you the syntax. Okay, so you just have to first access each element of this array, and then access the elements of that element. Okay, so since it is a multi-dimensional array, so first of all it is going to access these compartments individually, and then the individual elements in the compartment. Okay, so this is the way it is going to handle a 2D array. Okay, so in this case, one thing is important, that you must use this ampersand sign. Okay, so if you don't use the ampersand sign, then in that case, see this example, then in that case, uh, the type you would be getting here, it would be of the type insta. Okay, and then the inner for loop, it would become illegal. Okay, so in this case you must use references for if you want to get each and every element of your multidimensional array. Okay, so this is something important and you must know. And even if you want to use even if you don't want to write on these values, then you have to use constant type instead of just ditching the reference. Okay, so we are done with this using range for. Now we move to pointers to multidimensional array. Okay, so the thing I said uh, about the pointers to array, it would be very much applicable over here. Okay, so in this case, in case of pointers and multidimensional arrays, if you declare a pointer, then you have to specifically declare it like this. Okay, in star p4. So the reason for doing this is that bases should match. Okay, so the base of this array is 4. Okay, and so the base of this pointer should also be 4. Okay, so in this way you can have a pointer to a multidimensional array, and if you if you make your implementations, then it would be on base type of 4. Okay, so 4 elements would be incremented, and the counter here would move. Okay, so ia0, ia1, ia2, you can access it like that. Okay, so once you have defined declare this type of pointer, then you can also use this for pointing to any of the values of the multidimensional array. Okay. So int ampersand ia2, it would point to this element. Okay. So like I said, IA1, IA2, IA3, and so on. So it would point to the second element of an array which is having a base type of 4. Okay, base type of 4 means that it contains 4 elements in it. So if I am writing something like int ia ampersand sorry, p equal to ampersand ia2, then it means that here we don't have to supposedly ampersand ia1, supposedly this is int p equal to your p equal to ampersand ia1. Okay, so in this case it is pointing to this block. Okay, so this block is being pointed to by this pointer. Okay, so this has a base type of 4 and it is pointing to this block. So we are done with this. Now we would move to your type aliases. So type aliases can be used very effectively for simplifying uh, simplifying your multi or you're simplifying your multi-dimensional arrays. Okay, so you can use the using type aliases for your simplification. Okay, one thing I forgot to mention was this. You can use auto types to automatically detect the pointer type. Okay, so if you have written auto p equal to I, so in this case p would automatically become a pointer which is having a base type of 4. Okay, so since arrays are by default pointers, so the type returned here would be a base type or an integer array having a base type of 4. Okay, so like I said, you can use it for incrementing 3 times. Okay, so 0 1 2 3, it would move and show your values, and then you can dereference this thing, and when you dereference this thing, then it would also return you just a pointer of type int, and you can move that pointer 4 times to get all the elements. Okay, so this is one method of doing this. After this we were doing your type aliases for simplification. So you can use type aliases. Okay, so if you write something like using int array equal to int4, then whenever you would use int array, then it would just create an array of type 4. Okay, so if you write int your int array a, then it would mean that a is an array having size 4. Okay, so it can also be used like int a3. Okay, so this is equivalent to your equivalent to your a3 and 4. Okay, so this is thing. So we are completed with this thing, and next time we would be discussing about expressions, and okay, so we are done. Thank you.